So today we're going to look at how to power an Arduino Uno for your projects. A lot of the times you'll be powering it through the standard power supply, this socket here, or USB, but that's okay when you're developing a project. When you're actually running a project, you'll probably want to have a slightly more flexible solution. You may have another power supply in mind, something you're using for your project already. For example, in my project, which is driving a fan, I've got a 12 volt supply. This should be running 5 volts, so I'm going to need to drop it down to 7 volts. So I've got to figure out how to do that. First thing I need to figure out, Ohm's law is going to be our friend, and we want to figure out what level of power this is taking, how much current it draws. So we'll plug in some wires here. So there's one into the ground, and one into the V-in chip, the voltage in. You can see that there. I'll hook up my bench power supply, but I won't turn it on just yet. And now if you look at the bench power supply, we're operating in 16 volt range. It's currently not turned on. If we look at review, you can see that I've set it to about 5 volts and an upper current limit of no more than 200 milliamps, which is way more than it's going to use. But that should give a nice powerful voltage. That should give a nice steady voltage for the Arduino. So if I turn this on now, you'll see the Arduino is running. You can see the light on it. And you can see that under normal circumstances, this is drawing for just a regular program that it's on here, not sleeping or anything. It's drawing a current of 33 milliamps. So that's our target current. So what we're going to need to do is find a resistor that will drop 12 volts down to 5 volts if it's got a current of about 33 milliamps running through it. So you can do your Ohm's law or not, that sort of thing. You can figure out exactly what range it will be. Voltage equals current times resistance. Another approach, which is what I'm doing, is you can just play around with it. So for example, if we want to, one trick that I've figured out is, okay, we'll turn this off now. If I want to, one other thing I'm going to show you, when you're turning it on, you can see that as you turn the voltage up, it's drawing more current, like that's 50 milliamps, and the extra current will be dissipated through the power system here, but that'll heat up, so it's not optimal. Let's turn this back down to 5 for now, and in fact I'll turn it off. And what I'm going to show you is testing a resistor. And one easy way that I found to test a resistor, if you don't have a multimeter, obviously you should get a multimeter, but one quick and easy way if you've just got your bench power supply in front of you, is hook it up to the bench power supply. And because this measures voltage and current, you can actually, just using Ohm's law, figure out what the resistance of the thing is. So it's quite hard to read the bands on this, it's pretty small, and reading bands is fiddly anyway. The first things that I point out to you if you're going to do this is watch out for your current limits. You don't want to run anything more than, like a little resistor like that. Definitely don't want to run anything more than 100 milliamps through it. Otherwise it's just going to light up and smoke, and I made that mistake earlier. So I'm setting the maximum current to 90 milliamps, and now the voltage is currently 5 volts. If I turn it on, you'll see running at 5 volts is actually got 30 milliamps running through it, and that tells you the resistance. If I turn up the voltage a little bit, this will go up to like 50 or 60 milliamps, and that's about 10 volts. So that tells you with Ohm's law roughly what the voltage is. And then the trick is basically, we'll put it into the bench power supply like this, have our 2 rails coming in, and we'll have a resistor in series with the 12 volts, which will drop us down 7. I'll show you the calculations on the blog, and that's it. Look at Swift for Arduino, www.swiftforarduino.com.